This is HRW97P005. This is about the father. It says the father racing his son has... Now, the stuff in red is different from yours, but it'll be basically the same problem. His racing son has half the kinetic energy of the son, who has 1/3 the mass of the father. The father speeds up by 2.5 meters per second and then has the same kinetic energy as the son. Okay, first off, let's write down some pertinent information in terms of math here. Okay, first thing I know is the mass of the sun, hang on, thinner pen here. The mass of the sun is 1/3 the mass of the father. Okay, I'm writing that down. I also know that the initial kinetic energy of the father is half of the initial kinetic energy of the sun. Okay, then he speeds up. Now he speeds up such that the initial kinetic energy of the father plus speeds up by 2.5 meters per second. That's going to be the final velocity of the father. Okay, and after he speeds up, I know that the kinetic energy of the father equals the kinetic energy of the son. Notice I'm using F's on everything that has to do with the father, S's on everything that has to do with the son. If it's their initial whatever, I put a little knot on it, 0. And if it was your final, I just left it off, just like we did in all our kinematics equations. Okay, something else that it doesn't explicitly say, but I'm gonna write this down anyways. The sun did not speed up, so the initial velocity of the sun equals the final velocity of the sun. Okay, going to full screen now. Boom. All right, this is gonna get a little weird. Okay, I will try and keep it color-coded and all kinds of stuff for us. But, all right, let me try and walk this through. So, first off, I know from here, I'm going to go with this. I'm going to start here. Okay. Well, the kinetic energy of the father is, instead of writing that, I'm going to write the equation for kinetic energy. So, 1/2 mass of the father times the initial velocity of the father squared. Okay, that's this bit right here. Okay, equals 1/2, and then the kinetic energy of the sun is 1/2 the mass of the sun times the initial velocity of the sun. Okay, alrighty. Now I've got a couple things I can plug in. For instance, okay, keep this stuff on the left the same, then nothing there is going to change. But on the left, well, first off, I've got this 1/2 times 1/2. I'm going to go ahead and combine them, and that makes 1/4. Okay? But then look at this. Mass of the sun. The mass of the sun is equal to 1/3 the mass of the father. So I'm going to replace the mass of the sun with 1/3 the mass of the father. Okay, then I keep writing V0 S squared. Okay, all right, check it out. I now have mass of the father on both sides, so I can get rid of it. All right, so now what I have is 1/2 initial velocity of the father squared equals, I've got a 1/4 times a third, so that's 1/12. This is gone. All that's left is initial velocity of the sun squared. And you know what? Just to simplify it, I see I've got a 1/2 here and a 1/12 here. I'm just going to multiply both sides by 2. That'll get rid of this one. And instead of a 1/12, I'd multiply that by 2, I get 1/6. All right, that's about as best I can do right now. It's gotten much more simple than it was, though, right? Okay, I have one equation and two unknowns. I want the initial velocity of the father, and I want the initial velocity of the son. That's what the problem asks for in the end. I need another equation. Hopefully I'll get another equation with both of those in there. So let's look at this one. Kinetic energy of the father. The final kinetic energy of the father, well, that's 1/2 mass of the father times the final velocity of the father squared equals Ks. That's going to be 1/2 the mass of the sun times the final velocity of the sun. Okay. I'm going to do that thing again where I'm going to replace, keep this side the same. Oops. There. Sorry. Okay, 1/2. The mass of the sun is 1/3 the mass of the father. Let's replace that. And I'm going to do a little switcheroo here. Remember how we said the suns didn't change? So instead of writing VS, I'm going to write initial velocity of the sun, since the final velocity of the sun and the initial velocity of the sun are the same thing. So just made a little switch. Okay. Next. Well, I have another little thing to switch out over here on the left. Well, first off, I've got mass of the father on both sides again, so goodbye. Awesome. Then, also, I know that the final velocity of the father is equal to V0 F plus 2.5, so I'm going to replace that. Okay. So I've just replaced this with that. That's all I did. Equals 1/2. Well, oh, no, it's not 1/2 anymore, is it? I've got 1/2 times 1/3. That's 1/6. Well, initial velocity of the sun squared. Okay. Now, this is a polynomial that's been squared. I need to expand that. So what I have is 1/2, and then I don't know if you remember this, but from math class, probably a couple of years ago, whenever you do the square of a polynomial, what you do is you have the first term squared plus 2 times the first term times the second term. So I've got 2 times 2.5 times initial velocity, and then plus the last term squared. Boom. I've still got 1/6. Ooh, what did I just do that for? Okay, 1/6 V0 S squared on the right-hand side. So that stays. Okay, I'm going to distribute this 1/2 through. So if I distribute the 1/2 through, I get 1/2 initial velocity of the father squared. I've got a 1/2 times a 2 here, so I'm just going to get rid of them. So what I end up with is 2.5 initial velocity of the father. And then I'm going to go ahead and in my calculator I did 2.5 squared, and then I'm dividing it by 2, and when I do that I get 3.125. Okay, that all equals, well, that equals 1/6 V0 S squared, but look over here. Oh, not 1/2, 1/6. Did I say 1/2? I don't know. 1/6 V0 S squared, which is the same as this, that equals V0 F squared. So I can replace, those are exactly the same. So I can replace this with its equivalent, which is V0 F squared. Now look, I've got this one equation, and the only unknown in it is the initial velocity of the father. I can solve this. Now, unfortunately, what I have is a squared term, a linear term, and a constant. That just screams at me, quadratic equation! So I'm going to rearrange this to look like the quadratic equation, and everything's equals 0. So I'm going to, let's see, I'm going to, you know what? I like having my a be a positive number, so I'm going to just subtract everything over to the left. Everything's being subtracted over to from the left to the right. So on the right on the left I'm going to have a 0. On the right I'm going to have V0 F squared minus 1/2 V0 F squared. That will leave me with 1/2 V0 F squared. Okay, over here I had nothing, and then I'm going to subtract 2.5. So what I end up was 2.5, oops, there's a point there, V0 F. And then again, there was no constant over here. I'm going to subtract 3.125, so I end up with negative 3. Come on, stop doing that to me. 1, 2, 5. Okay, so now I've got this thing. It looks like that. Now it's time to do quadratic equation. Remember that your unknown equals negative b plus or minus the square root of b squared minus 4ac, everything over 2a. So, in this case, that equals, well, b is negative 2.5. Negative and negative is positive, so it's just going to be 2.5 plus or minus square root of negative 2.5 squared minus 4 times 1/2 is a. C is negative 3.125 all over, well, 2 times 1/2 is 1. So, there you go. Alright, I put this in my calculator, and I'm just going to scooch over here for a moment. Sorry. What I end up with is 2.5 plus or minus 3.54 over 1. I'm going to leave that off. Now, if I subtract it, I'm going to get a negative number. I don't think, if you go back and read the problem, the father did not run backwards. So I'm going to discard that and just use the plus, in which case the initial velocity of the father is 6.04 meters per second. Alright, I just solved one of them. To get the other one, I go back to one of our equations. Use green. Well, how about this one? And I've run out of room, so I'm going to turn the page. Okay, I know that the initial velocity of the father squared equals 1/6 the initial velocity of the sun squared. So to solve for the initial velocity of the sun, I'm going to multiply both sides by 6. So these go away. So what I get is 6 initial velocity of the father squared equals initial velocity of the sun squared. Square root both sides. Plug the numbers in, and I end up with that, oops, let's do it this way. Okay. If I plug in the initial velocity of the father that I just found, do all this, I end up with 14.78 meters per second equals the initial velocity of the sun. Let's just go take a look. Initial speed of the sun, 14.78. Okay, they rounded up to 0.8. That's fine. And the father, we came up with 6.04. Yep. So that's it. Kind of a longish problem, sorry, but one of my favorites because it's all algebra, basically. I just really like algebra.